Welcome to 6.2 substitution. So you guys, in this chapter, we are focusing on systems of equations. So again, what that means is visually, and this is systems of linear equations to be more specific. So if I have two lines that cross, right, the place where they cross, that coordinate right there, that is the solution to a system. Okay, so how that shows up is algebraically, this place, this xy value, whatever that is, right, that coordinate, that xy coordinate, is the only coordinate that you could plug in for x and y into the equation that makes the equation make sense. All right. So, and it has to make sense in both lines because that point is shared by both lines. So it's the only point that works with both lines. And then obviously there's a couple of other possibilities, right, where we have parallel lines or the same line. Then we have, more than one solution or no solution, depending. So today, what we're going to get into is solving this algebraically without a picture. So there's 3 steps to solving using substitution. All right, number 1, when necessary, solve at least one equation for one variable. What this means is, like, if I have y plus 2x equals 3, we want to make sure that we solve this for one variable. What I would do here, since the y is kind of by itself, is I would solve this for y by subtracting the 2x out from both sides. So what I'm left with is y equals negative 2x plus 3. Okay, so I solve for one variable. That's step 1. Step 2 then is we're going to take the resulting expression from step 1. Okay, that's this guy in parentheses. And then we're going to replace that variable in the second equation. Okay, so say originally we had another equation here that was like this. 3x plus 2y is equal to 3. Maybe we don't make it 3, maybe we make it 4. What I'm going to do for the step 2 is I'm going to take what I solved here and I'm going to insert it because I'm saying y is equal to this thing, right? Y is the same as this. So I'm going to take this and put it into my other equation for y. That's called the substitution. So we substitute the value from step 2 into either equation. That's the step 3 now. Once we plug it in there and solve for x, we take that x and plug it back into either equation to get our y value. So that's the steps. So jot these down in your notes. Make sure you're comfortable with the steps, but you will be more comfortable once we do one. Okay, so here's an example. Step 1, solve at least one of the equations for one variable. Well, lucky for us, they've already done it. Okay, so this one's already solved for y. So what I'm going to do is I'm going to take this 4x minus 6 and I'm going to insert it or substitute it in for the y value in the other equation. So what that looks like is this. Parentheses are very important here. 5x plus 3 times parentheses 4x minus 6. Whenever you substitute with parentheses, it becomes very important when signs are involved. Okay, so just make it a habit. Equal negative 1. All right, so let's go ahead now and solve this for x. Okay, so we have 5x plus, we're going to distribute, right? 3 times 4x is 12x. 3 times negative 6 is negative 18. It's equal to negative 1. Now we're going to combine like terms. Okay, what I'm seeing some of you guys do from time to time is try to, you're trying to move these x's separately across the equal sign or something. Like the first step when we're solving these algebraically is to combine like terms. So let's get the x's together. If you have 5x's and you add it to 12x's, you're left with 17x's. Minus 18 is equal to negative 1. Now I want x by itself, so I'm going to get rid of this 18. Okay, I want this x term. I want to get this guy alone so that I can divide by 17, final step. Okay, so I'm going to add 18 to both sides. And then I'm left with 17x is equal to 17. Divide both sides by 17 to get x by itself. And now we have x is equal to 1. So that's part of my answer, but don't stop there because it's a coordinate. Remember that the solution that we're looking for is a coordinate. Okay, an xy coordinate, I know that x is 1. Now you can take that 1 and plug it back in for either of the x's. Okay, so because this x has to be the same in both equations. So I'm going to go back into my first equation. All right, so we'll take this up here. The first equation was y equals 4x minus 6. So now I can say y is equal to 4 times, we're going to substitute 1 in for x. Okay, because we know what it is. Minus 6. The goal here is, you guys, if you have something in one variable, you can solve for that variable. Okay, if there's 2 variables, you can't. So we got to get it down to 1. Okay, so y is equal to, in this case then, 4 minus 6. So then y is equal to negative 2. So at 1, negative 2, these two things cross. And if you're nervous about that, whether you did that right or whatever, you could graph a picture of it, right? And take a look to see if those lines cross approximately there, and reassure yourself on your homework or your test. So example 1b, let's do another one. Okay, I'm going to have you guys do this one. But this one has a y equals, again, so the first step is done. We're going to insert it in, right? So we have 2x plus 5 times 3x plus 10. Notice I replaced my y value in the second equation with this 3x plus 10. That's all I'm doing. Okay, is equal to negative 1. Now we're going to just do some basic algebra. 5 times 3x is 15x. 5 times 10 is 50. Combine like terms. 17x here plus 50 is equal to negative 1. We're going to subtract 50 from both sides to get the x term by itself. We're left with 17x is equal to negative 1 minus 50 is going to be negative 51. Okay, and then x then is equal to, if I divide both sides by 17, I believe 17 goes into that 3 times, so we're left with negative 3. Okay, so our x value is negative 3. That's part of our answer. Now we can plug that back in. I'm going to plug it back into this guy because it looks easier. Okay, so I'm going to go ahead and plug it in there. So I get y is equal to 3 times negative 3 plus 10. Notice I used parentheses and I substituted what I knew, the negative 3, in for x. Then I'm left with y is equal to negative 9 plus 10. Negative 9 plus 10 is equal to 1. Okay, so I have negative 3 comma 1 for 1b. And let's keep cruising here, you guys. So some of them, like this one, we're going to have to solve for the variable first. I want to show you this one. This one, notice that there's not a single variable by itself yet. But also notice that this one is easy to solve for some variable. We could solve this one for y pretty easily. All I have to do is add 3x to both sides, and then I'll have y by itself, right? So I have y is equal to 3x minus 13. Now, once I have that, I'm going to take that and I'm going to insert it into my other equation for y. And it doesn't have to be y, guys. These turned out to be y. You could also solve for x just as easily and do this the exact same way. Okay, so now let's go ahead and put that in. 4x plus 5 times 3x minus 13. I inserted this guy for y. All right. That's equal to 11. Now we just distribute and combine like terms. So we have 15x there. 5 times negative 13 is going to be negative 65, I believe. Okay, we're going to combine terms here, like terms. We have 19x minus 65 is equal to 11. Make sure you guys are jotting these down in your notes, okay? Step by step with some side notation so you guys know what we did here. To get 19x by itself, I have to add 65 to both sides. So when I do that, we'll continue up here. We get 19x left is equal to 76. Divide both sides by 19. And when we do that, we get, should be 4, I believe. Hopefully it's just a solid 4. let's just confirm here. Here's an easy way to confirm. You can multiply it out. Yep. So it goes in 4 solid times. So x is equal to 4. Okay, so that's part of my solution. Now I'm going to plug it back into either equation. I want to choose the second one. So y minus 3 times 4 equal to negative 13. That's y minus 12 equals negative 13. Add 12 to both sides. And you get y left on this side, which is what we want, is equal to negative 1. So final answer, 4 comma negative 1. Okay, 2b, I'm going to let you guys do 2b out on your own. When you work 2b out, what I would recommend how you start this thing is start here and solve for x. Okay, so maybe I'll just show you that and have you guys finish it. So if I solve that for x, I need to add 3y to both sides. So I'm going to be left with x is equal to 3y, positive 3y, minus 9. Now I can take that, put it into this one for x, and solve. Okay, so when you do this, you should be getting 3 comma 4. All right. Example 3 is a no solution problem. Okay, so let's see what happens when we do this one. Notice they've already solved for y, so we're going to take that, plug it in here, and let's just take a look at what this looks like. So it's 2x minus 2x minus 3. Make sure you use parentheses, is equal to 8. Okay, so if you have a minus sign here, that means it's going to change all of the signs inside of here. That's why parentheses are so important. So we have 2x, think of it like a minus 1 out front. Minus 2x plus 3 is equal to 8. Notice that 2x minus 2x is 0. And we're left with 3 equals 8. Whenever you have a weird statement like that, like 3 equals 8, no solution. Okay, so no solution for that one. And then for 3b, we could have one that has infinite solutions. Remember for this one, by the way, when you graph these, this would be a parallel set of lines. For infinite solution, it'll be the same line on top of itself. Okay, so let's take a look at this one. So for this one, we need to solve for y first. That's kind of the steps for substitution. So let's get this. Maybe what we do is we take the easiest thing here. Let's just solve the first one for x. Okay, so if we did that, we'd have 4x is equal to it. Add 3y to both sides, right? So I get 3y plus 1. Then I would divide everything by 4 to get x by itself. X then is equal to 3/4 y plus 1/4. Okay, you got these nasty fractions, but it'll be okay. Hopefully they come out all right when we plug them in. So when I plug that in, I get 6y minus 8 times, notice I'm plugging this in for x because I solve for x. 3/4 y plus 1/4 is equal to negative 2. Okay, so let's distribute this out. 6y minus 8 times 3/4 is, that would be 24 over 4. 24 divided by 4 is 6, so I get minus 6y. And then negative 8 times 1/4 would be negative 8 over 4, which is negative 2, equals negative 2. Okay, so 6y minus 6y, notice this goes to 0 just like it did with the no solution, but then I'm left with negative 2 equals negative 2. When is that the case? Always. So this is an example of all reals. When you get the same thing equal to itself with no y's or x's and those things cancel, that just means that you have the same line. So you're on your solution to the same line graphed twice would be infinite solutions. All right, the last thing here, example 4, as of 2009, the New York Yankees and the Cincinnati Reds together had won a total of 32 World Series. The Yankees had won 5.4 times as many as the Reds. How many World Series had each team won? Okay, so they want you to solve the system here. So we have the Yankees y plus the Reds r is equal to 32 wins. Okay, then we know something about the Yankees, right? The Yankees won 5.4 times as many, so I could say the Yankees wins are equal to 5.4 times the Reds wins. Okay, so that's kind of how you would set up a problem like this. Then you could take this y equals and substitute it in for the y. So you have 5.4r plus r is equal to 32. So you have 6.4r is equal to 32. Divide both sides by 6.4. And then r is equal to, I think when you do this, you get 5. Is that right? Let's see here. Well, let's take 6.4 and multiply it by 5. Yes, so the Reds have 5 wins, which means we can now plug that back in, right, for R. So that means the Yankees must have, just plug it back in, subtract 5 from both sides, 27. Okay, so that's how you would set up a word problem like that. You need 2 equations for these systems. Alright guys, that's it for now. Homework, I'll have homework sheets for you guys, so don't worry too much about the page number here, or the numbers, because I think those might be off depending on the textbook you're using. We'll catch